This is lesson 6-8, graphing absolute value functions. So we're going to review some stuff about absolute value and learn some new vocabulary here along the way. So if you recall, taking the absolute value of a number makes the number what? If you filled in the blank with positive, you're correct. The graph of an absolute value function looks like a what? If you filled in the blank with v, you are correct. The parent function of any function is the simplest type of graph of any function. And the parent function for absolute values functions is y equals the absolute value of x. Graphs of the absolute value function can change based on any operation that we perform to the parent function. And the act of graphing based on changes to the parent function is called translating or transforming, depending on what you are doing to the graph. So let's take a look at the graph of the parent function. Take a look at my chart to the right, and we have graphed these types of functions before using the chart method. We did this last chapter. So let's use the chart method and figure out the graph of the parent function. Filling in my chart, I have y equals the absolute value of negative 2, which is 2. Y equals the absolute value of negative 1, which is 1. Y equals the absolute value of 0, which is 0. Y equals the absolute value of 1, which is 1. And y equals the absolute value of 2, which is 2. Plotting my points and graphing the function, I've plotted my points here on the right, and I will connect the dots and put arrowheads on the end of the line. And again, the graph of the parent function, the absolute value parent function, is a v. It's very important to memorize what this looks like as we move forward. Here's the chart that I gave out in class. I have what happens when, a change, and function. I'm going to explain on the next slide how to do the graph. A copy of the chart is available on my website. So, how do we do the chart? The first thing you want to do is go to www.desmos.com/calculator. From there, you want to type in the parent function and graph it, y equals the absolute value of x. Then, perform any indicated change depending on what line you're working on in the chart. Substitute any number you want for the letter h. Then, graph that new function on Desmos. Describe what you see happening in the change column. Is it moving somewhere? Has the graph stretched, or has it flattened at all? Describe what you see in the change column. Then, write your new function in the function column. On the next slide will be a demo of Screencastify as to how to do Desmos. So here's a demo of desmos.com/calculator.
So we have.
So once I get to the screen here, and again, make sure in your address bar that you have
screen.
It's spelled
So
exactly
that's what you want to put in your
correctly.
address bar. If you don't see the address bar, it's up here. Again, please make sure
Desmos.com/calculator.
you spell it correctly. So when you're doing this
If
for
you don't
your
know where the
chart,
address bar is, I just moved my cursor up to it right
simply
there.
just use this
It's very
pad
important that
down
everything
here
is
where my
spelled
cursor
correctly
is,
when you're doing that.
and use that for your
So now I want to type in my
you always
parent
want to put the
function.
parent function in.
I'm going to
So
hover over,
y, and then
I'm going to click on the
and then
y.
The absolute value is down here where the a and the bars are, and we'll put in x.
Then the
and you can see
equals.
there it is. It appears on the screen very
The absolute
nicely.
value is the A bars
Okay,
right there.
I'm going to move it over a little
I'm
bit
going to
so
click
it's in
on
the middle
that,
of the screen.
and I'm going to click on the X.
Okay.
Now notice that my
And
graph shows up. I'm
So
just
then
going to move
what
it
I'm
over a
gonna do,
little bit so
like
that
for the
we're in the
first
middle.
one we did with adding a number
My
to
graph
the
shows up
outside of the
perfectly.
bars. Okay,
Now
I'm
to
gonna
get
pick
to the
any
next
number that
line,
I want to add
I
to
want
the
to hit
outside of the
enter,
bars.
and that's where I'm going to start my
So
comparisons.
I hit
But I
enter,
want the
by
parent
way, to get to
function
that,
on the line and
next
graphed
line.
out.
So now I have y.
So now I've hit
equals
enter.
the absolute
And
value
now I'm
of
going to put in
X. Now
my
I'm going to
first
use
line.
my right
So I
arrow
want to add a
button
number to the
get
outside,
the bars,
like it
then
says in
I'll
the
put
first line. So I do the
plus,
absolute value of X. I'm going to hit my right
and then,
arrow,
for example,
so I go
maybe
outside
1.
the absolute value
and notice
bars,
that the
and then I'm going to type in something
absolute
like
value
plus,
graph moves
let's
1
try
unit
1.
up the y-axis.
And I
So
can
in your
see
change
on the
column,
graph
you would
that it
put
moved up 1
in the
unit.
change, you would put moves up the y-axis, and then H units because we want to
When I
do
write
it
my
so
report
that,
for the change,
it's for any number
that's
that we
what I
put in.
want to
In fact,
write
if you
in
see
there,
if
is
I
that it's moving
backspace here
up
and put a 2,
the y-axis
okay, so you're going to see
a
it moves
certain
up
number
2
of
units.
units.
Okay, if I did 1.5, it'll go 1.5 units up.
I'm just testing it here to see that my theory holds. If I do it 2 units,
that's how you
I
will
move
do
it
the
up
rest of your
2
chart.
units. If I do it 1.5 units, I move it up 1.5 units.
/calculator.
This is the end of day 1 of this lesson. Please pause the lesson until further instructed to do so. Let's go back to the chart that we did on day 1. Let's take a look at what the change and function columns should look like. For the first one, it moved up H units. You can also put that it was on the y-axis that it moved up. Second one, it moved to the left. Third, moved down. Fourth, moved to the right. Fifth one, made the graph skinnier. Now remember, for multiplying, it doesn't matter if you're on the inside or the outside of the bars. The same thing will happen. When it's between 0 and 1, in other words, it's a fraction, it makes the graph wider or flattens it. And if you multiply it by -1 on the outside, now this one has to be on the outside because if you multiply it by -1 on the inside, the absolute value will take over and just make it positive. So multiplying by a negative must be on the outside, and it just reflects the graph over the x-axis. When you're explaining and graphing translations, the first thing you want to do is to realize that absolute value graphs can be one or more translations of the original parent function. When you're graphing and describing translations, your order of graphing such does not matter. Here's an example. Explain how the graph of y equals the absolute value of the quantity, x plus 1, minus 7, differs from the parent function, y equals the absolute value of x. I have two things going on here. I've added 1 to the inside of the bars, and I've subtracted 7 from the outside of the bars. So my answer is that the graph will move 1 unit to the left because of the plus 1 inside the bars, and down 7 units because of the minus 7 outside the bars. Let's take a look at a graphing example. Graph the function y equals the absolute value of the quantity, x plus 1, minus 4, and explain how it relates to the graph y equals the absolute value of x. Pause the video at this point to give yourself a chance to do the work on your own. So the first thing we're going to do is graph the function. Plus 1 on the inside moves it 1 unit to the left. Minus 4 on the outside moves it down 4 units. I create the same exact graph as the parent function, a v. Make sure that your graph goes edge to edge. Explaining how it relates says that the graph is moving 1 unit down, 1 unit to the left, and 4 units down. If you're having any trouble with this lesson, please consult your teacher in class.